will decide the type of the addressing mode is being stored at the word which is having its address as 200. It's given in the question, and the remaining part of the instruction, that is your address part, it is being stored at the location 201 in the memory. Again, it is given in the instruction, and as 200 is the beginning address of this instruction, that's why the value of PC is 200 given. It is by default, it will be of that value of the address at which the instruction is being stored. And other than that, some more registers, some more values are given कि आपका एक इंडेक्स एक जनरल पर्पस रजिस्टर गिवन है, that is consisting of the value as 400. It is again given, and will make use of all these values in finding out the effective address of all the addressing modes as per their definition wherever it will be required. And one more register is given, the value of one more register, and it is called as your index register. XR stands for the abbreviated form of your index register, right? And it is again being used in order to calculate the value of your effective address as per the definition of your index addressing mode. And then AC stands for your accumulator register. In this question, all these values are given, but if you do talk about any other question, maybe in exams these values may be customized. It's not every time कि ये value ही आपकी use होंगी. Different values may be there. Index register में कोई और value आपको मिल जाएगी, R1 में कोई और मिल सकती है, and maybe memory would have consist of a number of words, not exactly the number of words as mentioned in this memory. और आपकी sometimes जो आपकी instruction है, it may be stored in one word capacity. So this way the changes may be done, right? So we'll begin from the direct address. Direct address में आपने कैसे find out किया आपका effective address as well as the content of AC कि you will as per the definition of direct address, आपका जो whatever is the value of the address in as a part of a instruction format of the instruction, you need to go there 500 basically. You need to go to the location of 500. There, whichever the value you will find, that value will work as the final value of your operand. और आपके given instruction क्या है? Load to AC. So whatever is the kind of the instruction is given to you as per the definition of that instruction, that as per the function of operation of that instruction, this value will be loaded to this value 800 will be loaded to AC. So this 800 ultimately will become as the final value of AC. So you can view that content of AC now will be 800. Why? Because we are going to talk about direct address instruction, and as well as आपका क्या होगा कि आपका इफेक्टिव एड्रेस क्या होगा, इसका जो फाइनल एड्रेस है दैट विल बी टर्म्ड एज योर इफेक्टिव एड्रेस. तो 500 विल वर्क एज योर इफेक्टिव एड्रेस. नाउ वी कम टू द नेक्स्ट एड्रेसिंग मोड, दैट इज इमीडिएट ऑपरेंड. अब इमीडिएट ऑपरेंड की डेफिनेशन क्या थी आपकी कि जो पार्ट एड्रेस का इंस्ट्रक्शन में एड्रेस का पार्ट है दैट इटसेल्फ वर्क्स एज द फाइनल वैल्यू ऑफ द ऑपरेंड. मतलब कि आपका जो 500 है दैट इटसेल्फ इज वर्किंग एज द वैल्यू ऑफ द ऑपरेंड, और वो एज पर द फंक्शनैलिटी ऑफ लोड टू एसी ये 500 वैल्यू अल्टीमेटली कहाँ आफ्टर द एग्जीक्यूशन ऑफ दिस इंस्ट्रक्शन वैल्यू कहाँ जाके स्टोर हो जाएगी, एक्यूमुलेटर रजिस्टर में हो जाएगी. सो आफ्टर द एग्जीक्यूशन ऑफ दिस इंस्ट्रक्शन लोड टू एसी एग्जीक्यूशन एज पर द इमीडिएट ऑपरेंड, एसी की वैल्यू रिजल्टेंट वैल्यू क्या बन जाएगी, 500 बन जाएगी. और आपका इफेक्टिव एड्रेस क्या होगा, इफेक्टिव एड्रेस होगा जहां पर आपका फाइनल ऑपरेंड स्टोर्ड है. तो ये आपका फाइनल ऑपरेंड 500 है, कहां जाके स्टोर है, 201 में. तो 201 विल वर्क एज द योर इफेक्टिव एड्रेस. Now we come to the indirect address. Now as per the definition of the indirect address, how it works कि ये जो address है ये indirectly is being used in order to locate the value of the operand. मतलब पहले कंट्रोल आपका 500 पे जाएगा, फिर 500 पे एक वैल्यू मिली, this further will work as the value of the address. फिर 800 पे कंट्रोल जाएगा, you have to find out the 800 value 800 throughout all these values. So 800 पे जाके जो whatever the final value you are going to get, that will be called as the value of operand to be loaded in your accumulator register. तो ये 300 value ultimately will be loaded into the accumulator register in your indirect address. तो indirect address में आपका क्या होगा, ये 300 आपका क्या होगा, accumulator की वैल्यू बन जाएगी, और इसका जो एड्रेस है वो आपका क्या होगा, इफेक्टिव एड्रेस होगा. तो 800 will become as the final value of the effective address in case of your indirect address instruction. Now we come to the relative address. अब relative address आपका क्या कहता है, relative address कहता है कि how the effective address is being calculated. It says that the address part of the instruction is being added to the address of the next instruction in order to calculate your effective address. Relative address, let me show you. So what it says that address of the program counter for the next instruction is added to the address field to get the address of the operand. So that will be called as the effective address. Means address part of this instruction मतलब 500 will be added to the address of the next instruction, और next instruction का address क्या है 202. So ultimately effective address क्या बन गया 500 plus 202 क्या बन गया आपका 702. So that 702 will work as the effective address. अब 702 को search करो यहाँ पर is throughout all the addresses, then you will find out कि 702 you are being able to get it here. So 702 के against whichever is the value you get, that ultimately will work as the value of your operand. So this operand ultimately will be loaded in the accumulator register. So 325 will become as the final value of your content of AC, and 702 will become as its effective address. So this is the, as you are all the time you have to go by the definition of your addressing mode. The definition of you have to go by the definition of the effective address in the respective addressing mode. Now we come to the index address. What is the definition of the index address? It says that you need to add the value of the address of the given instruction into the value stored into the some value stored in your index register. So here we are given an index register, and which value is being stored. Earlier which value is given, 100 is given, and what is the value of the address as the part of given as the part of your instruction? This is a 500. So in case of your index address, what will become the formula of to find out the effective address? This 500 will be added in the value of the index register, that is your 600, so as to become as your final effective address. So final effective address index register में क्या बन गया आपका 500 plus 100, 600 will work as your final effective address. Now you need to locate, you need to go through all these addresses in order to find out the value 600. At this point you get the value of 600. Now whichever value is there in the respective word, that value will work as the final value of operand. Now 900 you got it, this 900 and ultimately will be loaded to AC as per the definition of, as per the functionality of the given instruction. तो ये 900 आपका AC में जाके लोड होगा, तो AC की resultant value क्या बन गई आपकी 900 बन गई. You can see in this table 900 has become the final value of AC, and which is the effective address, कौन सा हुआ 600 will work as a effective address. Next we come to the register addressing mode. What is the definition of the register addressing mode? It says that कि जो general purpose register given है, that will work as the value of your effective address. And यहाँ पे आपके register की value 400 given है, so you need to locate in the memory कि 400 पे कौन सी वाली value operand की store है. At the location of 400 you can find out that the value 700 is being stored. तो 700 जाके load हो जाएगा AC में. So 700 will become ultimately the value of your accumulator register in case your addressing mode is your sorry, this was the definition of register indirect mode. Now there are two kind of the register addressing mode. One is a register, one is a register indirect mode. Register basically is a similar kind of direct address. You can basically map it to the direct address, and indirect address memory reference instruction, but rather it is register addressing mode and register indirect mode. What is the definition of the register direct mode, rather the register mode, register addressing mode? It says that how to calculate the effective address and how to calculate the value of final operand. It says that whichever the value is stored in register, at this itself will become as the value of the operand. Right, this itself will become as the value of the operand. मतलब which instruction was given to you, load to AC, और load to AC क्या करेगा? What is the functionality of load to AC? Whichever is the value of the operand found somewhere either in memory or in register, that ultimately will be loaded to AC. Right, so you have to go by the definition of all these addressing modes in order to find out the effective address and the content of AC. So as per the definition of register direct address, what it says that whichever the value is found in register, that itself will become as the value of the operand, and that will be loaded into AC. And So what will be the value of AC in this case? 400 will become as the AC, but here no address is specified, so that's why, so address part will remain vacant. That is why a dash is put here in front of it. Now we come to the register indirect. What is the definition of register indirect? Register indirect says that whichever the value is given in the given register, general purpose register, that itself will become as the effective address. At that location only the operand will be found. So you need to find out. You need to locate this 400 value throughout all addresses. You will find out that against this 400 value, you are being able to find out the value of the operand. So 700 will become as the value of the operand that will be stored load to AC, that will be loaded to AC as by the definition of this instruction, and the content of AC will become as 700 after the execution of this instruction, again in case of your register indirect, and whatever is its address, final address, this final address will be called as the effective address. Now the effect 400 will work as your effective address, and 700 will work as your final value of the operand that ultimately will be stored in AC. So content of AC after the execution of this instruction will be as your 700. And then is the last two addressing modes are left. One is the auto increment and other is the auto decrement. What auto increment says? Auto increment says that first of all, let me show you the definition of register and register indirect. I will share this PPT with you, and register indirect. What is the definition given? It is given that the address field contains the name or unique number of the CPU register which contains the operand. It basically consists of this instruction part consists of the value of the register. It consists of the address which ultimately is stored in the register. This register is the part of this. Contains the name or unique number of the CPU register which contains the operand. But it will contain this part will consist of the specification or reference of this register that ultimately is being consisting of the value of the operand. And register indirect mode, it says that the address field contains the address. You may be asked to write down all these definitions as well. 1 mark definition may come up in your exams. The address field contains the address of a register, address of the register at which ultimately the final value of the operand is being stored in the memory. So this is the definition of register and register indirect address instruction. Now we come to the next two addressing modes, auto increment and auto decrement. These are equivalent to your register indirect except this definition. Similar to register indirect mode, except that the value of the register is incremented or decremented after or before it has been used to access memory, and usually used to refer to a table of data. What it says? Register indirect says that auto increment says that what has to be done. Again, it will work in a similar manner as the register indirect was working. What was the definition of how the register indirect was working? You need to locate, you need to find out the value of R1. Yes, 400 is there. You need to go to the location 400 in the memory, and you will find out this value 700, and 700 is finally loaded into the accumulator register. And the definition of the auto increment says that whichever is the value given in register, that will be incremented or decremented. In case of your auto increment, it will be incremented after its value has been used. So do remember this thing, after its value has been used. So once instruction has made use of the value of R1, afterwards later on the value of R1 will be incremented by 1, and later on the value of R1 will become as 401. But prior to that, this instruction will be executed as per the 400 पे. The control will go to the 400. 700 आपको मिला, 700 will be loaded to AC. So AC के इसमें contents क्या बन गए? 700 ही बन गए. So if you view कि register indirect और auto increment में exactly same contents are there. Content of AC दोनों में 700 है और effective address दोनों में 400 है. The only difference is that in auto increment, after the execution of this instruction, what will happen? The resultant value of R1 will become as 401, though it's not visible to you because we are talking at the moment only the execution of one instruction. But in case Any other instruction will have to make use of the value of this register again, so it would have it will make use of the incremented value 401 in place of 400. That only will be the impact. Now, so it will,
Ma'am,
these two values exactly will
ma'am,
be, yes please.
ma'am, I have a doubt. Ma'am, here we are storing the word into मतलब दो हम उसमें
Yes,
स्टोर कर रहे हैं मैम ये
exactly,
तो
exactly.
मैम वो 4021 तो नहीं होगा देन
बेटा ये ना ऑटो इंक्रीमेंट, इसका उसका मेमोरी स्टोर करने से कोई रिलेशन नहीं है. जो मेमोरी के अंदर एक
मैम
इंस्ट्रक्शन जो है टू वर्ड कैपेसिटी में स्टोर है, हाउ इट इज रिलेटेड टू दैट? इट इज नो वे रिलेटेड. वी हैव टू गो बाय इट्स डेफिनेशन कि R1 की वैल्यू यूज करने के बाद 401 हो जाएगी. दो इट इज नॉट विजिबल टू यू, इसका इंपैक्ट इस प्रेजेंट इंस्ट्रक्शन पे नहीं आएगा. इसका इंपैक्ट आएगा अगर कोई और नेक्स्ट इंस्ट्रक्शन फिर से लोड टू एसी होता, फिर से हम एड्रेसिंग मोड में इफेक्टिव एड्रेस फाइंड आउट करते, then in that case it would we would have made use its incremented value 401 in place of 400, right? So it present instruction पे it is having no impact. Yes, still any doubt you can ask.
मैम आई वाज
Yes,
सेइंग
ma'am.
कि यहाँ पे
Excuse, ma'am.
Yes please, yes beta.
How about the 450 in the inside the memory? That is line to 399. How do we get it?
Beta, your voice is not audible. Can you please repeat? Yes please.
Ma'am, I'm saying the value of auto increment, which is auto decrement, which is 399. Where do we get the value of the operand 450 from?
Beta, I'm coming to that. I'm coming to the definition of auto decrement as well. I'm going to explain. Okay. So the definition of the auto increment says that it works in a similar manner as the register indirect works. What it says that in case of an auto increment, value of R1 will be incremented once its value has been utilized. Once its value has been utilized. Matlab, at present, what we have to tell? We have to tell the value of accumulator register after the execution of this instruction, which has been earlier been stored in the capacity of 2 word, and we have to find out its ineffective address in each of these addressing mode. In case of a auto increment, how will it work? It will work in a similar manner as a register indirect mode. So as per the indirect mode, how will it work? It says that go to 400, but try to find out the value of operand. That operand ultimately will be loaded to accumulator register. So this 700 will become the value of AC only, and this value of R1 AC, and this 700 का आपका क्या effective address? This is your effective address. So far as the effective address and content of AC is concerned, for the execution of this instruction corresponding to the auto increment addressing mode, these two values will same as exactly in case of a register indirect. But at this register, while lying in this value lying in this, it automatically will get incremented. It will become as 401, though its impact is nowhere visible at this moment. Right? Now we come to the auto decrement. If you would have say if here one more instruction would have been given, and we would have asked again in a similar manner ki, if the instructions are being executed sequentially, then you would have to find out the value of effective address. Then you would have gone for by taking the value as 401 in place of your 400. Right? In that case, or in the next instruction, they would have been the impact. Now we come to the auto decrement. What is the definition of the auto decrement? Auto decrement says that, see, whatever the addressing mode we are going to talk about, we have to take all these these values as the initial values. If some kind of the changes happen in these values, we don't have to go by that. We have to think each of the addressing mode independently, right? So what is the definition of auto decrement? It says that the value of register gets decremented by 1 before I am focusing on the word before its value is being utilized by this instruction. So that means before searching for the data, before searching for the operand, prior to that, the value of R1 gets decremented. Now its value will become itself 399. Now at the location 399, we need to find out. Now we talk about the execution of this instruction. It says that load to AC, and from where the data has to be taken from the memory at the location 399, because it gets incremented, it becomes 399. Now go to 399, right? And you found the value as 450. 450 will become as the value of your accumulator register. 399 will become as an effective address. So this is all about all your addressing modes. If you do have any kind of the doubt, you can ask.
So how do we obtain that 450?
Yes, please.
How do we obtain the 450 that we get in the line of 399?
450 beta. See, you joined the class very late, and I earlier had provided you the recorded lecture to listen to you to listen. Actually, this memory, all these details, specifications, memory specifications, and all details are given as a part of your numerical question. It is given that this is a memory divided into a number of words, and all these are the addresses of different words. And here at the location of 200 2012, here the instruction is being stored in the capacity of two words, and that is beginning from the address 200. So this instruction, which is consisting of three parts, load to AC, mode, and address part, it is not being stored in one word capacity, it is being stored in two word capacity. The top two components, load to AC and mode, are being stored at the location 200, and address part is stored at the location 201. It's given in the question. We are doing nothing with all these values. It's given that at 400 location 700 the value is stored. All these are the values of the operand stored at the respective locations. These are the locations of the memory. So it's already given that at the 399 location 450 is given. So and similarly all these values are already given, that PC consists of 200. Why? Because PC is going to point to the very first instruction, and value of R1, that is a general purpose register, is already given as 400. Value of index register is already given as 100. And based on all these specifications corresponding to all these addressing modes, you would be asked in exam to find out the effective address based on all the specifications given in the memory and based on the specific instruction given in the memory. And you have to find out the content of AC. At this moment, the load to AC, load instruction is given. What is the functionality of the load? Load will load the specific value of the operand retrieved from the memory, and ultimately it will load into the AC. And there may be another kind of the instruction could also be given here, like in place of load, add can also be given, add to AC. So how in that case add would have been worked? It would have extracted the value from operand, then it would, and some of the initial value of AC could have been given, and then the value would be added to AC, and afterwards the resultant will be loaded back to the AC. So it all depends on the nature of the functionality of the instruction, how ultimately the final resultant value is being obtained. Is that okay? Should I continue with the next concept?
Yes, ma'am.
Yes, please.
I want to ask you something. मैम, जैसे हम यहाँ पे ये डायरेक्ट एड्रेस या जैसे इनडायरेक्ट एड्रेस ले रहे हैं, हम बता रहे हैं कि वो एड्रेस बिट उस चीज को सिग्निफाई कर रहा है कि वो हमें डेटा कहाँ पे मिलेगा. ऐसे मैम ये जो ऑटो इंक्रीमेंट और ऑटो डिक्रीमेंट है, ये क्या सिग्निफाई कर रहा है यहाँ पे, काइंड ऑफ कि इससे हम क्या बताना चाह
एड्रेसिंग मोड का सिग्निफिकेंस क्या है? एड्रेसिंग मोड का मतलब वी आर नॉट कन्फाइंड टू अ वन वे ऑफ एड्रेसिंग द ऑपरेंड. फ्लेक्सिबिलिटी बढ़ा रहा है, ये फ्लेक्सिबिलिटी बढ़ा रहा है टू रेफर टू रिट्रीव द value of the operand from memory. We are not restricted to only one way of locating the data from memory, right? तो ये scope बढ़ा रहा है, and it all depends on the type of the application कि वो internally कैसे work कर रही है. इंटरनली सिर्फ एक ही एप्लीकेशन में, तो इसी टाइप के एप्लीकेशन में तो आपका एड्रेसिंग मोड यूज नहीं होगा ना, और डेटा की रिक्वायरमेंट आपकी मेजरली द बिग एप्लीकेशंस में भी हो सकती है, और रियल टाइम एप्लीकेशन में भी हो सकती है, और एनी डे टू डे एप्लीकेशन में भी हो सकती है, डिफरेंट काइंड्स ऑफ प्रोसेसिंग में हो सकती है. सो दैट इज व्हाई टू एनहांस द फ्लेक्सिबिलिटी ऑफ लोकेटिंग द वैल्यू ऑफ द ऑपरेंड, द डिफरेंट एड्रेसिंग मोड्स आर इंट्रोड्यूस्ड, राइट?
मैम हार्डवेयर में ये सभी होते हैं, मतलब कैसे, लाइक
बेटा ये सारे के सारे आपके सीपीयू में बिल्ट इन है. बिल्ट इन में इट सीपीयू इज गोइंग टू सपोर्ट इन अ बिल्ट इन relative address mode or index addressing mode basically समटाइम्स बेसिकली ये क्या करते हैं कि रिलेटिव टू सम काइंड ऑफ एड्रेस, इट्स नॉट एवरी टाइम कि हमेशा हमने एक जगह से उठाया और दूसरी जगह पे जंप लगा के डायरेक्टली इनडायरेक्टली उठा लिया, समटाइम्स उसकी थोड़ी सी डिस्टेंस पे कहीं डेटा पड़ा हुआ है, तो रिलेटिव विल वर्क इन दैट केस कि आप यहाँ तक कंट्रोल पहुंचा हुआ है, रिलेटिव के रिलेटिव मतलब वैल्यू ऑफ सम रजिस्टर इज बीइंग एडेड टू द नेक्स्ट इंस्ट्रक्शन in order to obtain the final address. So sometimes some kind of the application is of such nature कि आपके एक पॉइंट पे एड्रेस पहुंचा हुआ है तो उसके रिलेटिव टू दैट लोकेशन एक नया एड्रेस निकालना है. So then in that case the index register or relative address are used in those kind of the cases. So it depends on the nature of the application. Okay.
Yes, ma'am.
Now I would switch to the next section. अच्छा, ये है आपका सिस्क एंड रिस्क आपका आर्किटेक्चर है. This is complex instruction set computer, and this RISC stands for the reduced instruction set computer. And only the brief description of this CISC and RISC are there in your course, and you only have to write down the characteristics of all these. So I will share the slide with this PPT with you, and the basic characteristics are given, and that you can elaborate. And it's mentioned in section 8.8. Complex instruction set computer. What it says that a computer with large number of instructions, 100 or more, comes. This is the type of the processor. This is the processor which is a complex kind of a processor, and reduced instruction set computer is that kind of a processor that consists of the fewer instructions with simple constructs. So that is the main difference. And RISC, what are the different characteristics of CISC? CISC is complex instruction set computer. The software costs far exceed hardware costs. Here the cost is high in comparison to and if you do talk about the software cost, and if you do talk about the hardware cost, then the software cost is comparatively higher than that of your hardware cost. And increasingly complex high level languages. So what kind of the programming languages it supports? Basically the complex kind of the, because its architecture is complex, it supports large number of instruction sets, it supports more number of addressing modes, and that's why it's also support the high level programming languages. And easier compile writing, improve execution efficiency, complex operations in microcode, like in day to day the systems that we are going to talk about, those are basically the comes under the category of CISC. And the RISC is basically the initially when the system was introduced, then only that for the basic computer we can talk about, that was the RISC based. Even prior to that, even that was based on RISC based. So CISC mein kya, what are the characteristics? A large number of instructions are there, some instructions that perform specialized tasks and use infrequently, a large variety of addressing modes are there, variable length instruction format, and instructions that manipulate operands, means more kind of the flexibility, more support of instructions, and more complexity in every manner is they are incorporated in your CISC architecture. And in RISC architecture, it basically supports limited functionality. Relatively few instructions are there, so it is restricted to those kind of the functionality of those instructions only. Relatively few addressing modes are there. Memory access also is limited. Load and store instruction, only load and store instructions are confined to the memory reference instruction. Only we have the get access to only these two kind of the instructions in the RISC architecture. But that the architecture that we are studying in as a basic computer even talks about your CISC architecture. In basic computer is based on the whatever the kind of the list of the instructions we are studying and addressing modes that we are studying that support the CISC architecture. All operations done within the registers of CPU. And fixed length easily decoded instruction, but there are the elementary kind of architecture, you may call it as your RISC architecture. So this much you have to do for your RISC and CISC architecture. And based on this section 8.5, I already have given you the assignment that you have to submit me, that is an open book test. Right, you can take the help of your book in solving the questions, but those questions are not from the back exercise. I have taken few of the questions from your last year question papers. Now I would like to show you the copy of the ebook. Afterwards, I will switch to section 8.4 as well and 8.2. So let me go to the back exercise. Of 8th chapter. We are coming to 8th chapter, back exercise. Have you started solving the questions of the assignment that I had given you? If you have not started yet, you have to complete it. You have to give a sitting tonight, and you have to submit me by tomorrow morning. That is a deadline. And if no copying and pasting is allowed, you have to solve all questions from your own hand, And moreover, if you are having any kind of a doubt, then you can discuss. I hope now you will be able to solve those questions.
मैम अगर हमें इंस्ट्रक्शन छोटा करना हो तो कैसे करेंगे?
छोटा करने का क्या मीनिंग है?
जैसे 12 बिट्स है एड्रेस, अब अगर मुझे उसे 4 बिट्स बनाना है तो मैम कैसे
क्यों
करेंगे?
बनाना है?
मैम अगर हम यही इन्हीं इंस्ट्रक्शन जो ये हमारे थे डायरेक्ट एड्रेसिंग मोड, इनको यूज करके।
नहीं, आई कुड नॉट गेट योर क्वेश्चन कि किसी इंस्ट्रक्शन को छोटा क्यों बनाना है। देखो, आपका जो सीपीयू है वो स्टैंडर्ड साइज के रजिस्टर्स को सपोर्ट कर रहा है। इट्स नॉट इन योर हैंड। अगर आपका इवन इफ आपका इंस्ट्रक्शन का साइज छोटा है, बट अल्टीमेटली आफ्टर द एग्जीक्यूशन ऑफ द फैच इंस्ट्रक्शन, दैट दो इंस्ट्रक्शन इज ऑफ द कैपेसिटी 8 बिट्स से, so that ultimately will be stored in the capacity of 16 bit if the CPU is making use of those kind of the registers. अगर CPU का रजिस्टर का साइज 16 बिट या 32 बिट जो भी स्टैंडर्ड साइज है उसमें जाके स्टोर होगी, और जो बाकी वाली रिमेनिंग वैल्यूज है those will be filled with zeros. Yes,
Excuse me, ma'am.
is that clear, or you want to ask?
Ma'am.
Yes.
I'm in question number 2 of assignment. Base register value is also given. What is the use of that value?
Let me see. So it will work in a similar manner. आपका I think आपका PPT में it's mentioned कि अगर आपका let me go through the PPT. जैसे आपका इंडेक्स एड्रेसिंग मोड था, आपका रिलेटिव एड्रेसिंग मोड था, उसमें आपका इंडेक्स रजिस्टर या जनरल पर्पस रजिस्टर गिवन था। इन ए सिमिलर मैनर यू हैव बीन गिवन अ बेस रजिस्टर, उसमें कुछ वैल्यू इनिशियलाइज है रिलेटिव ये देखो, यू गो बाय दिस डेफिनेशन इन ऑर्डर टू कैलकुलेट द वैल्यू ऑफ इफेक्टिव एड्रेस। क्या कह रहा है बेस रजिस्टर एड्रेसिंग मोड की कैसे कैलकुलेट करनी है इफेक्टिव एड्रेस को? कंटेंट ऑफ बेस रजिस्टर प्लस एड्रेस ऑफ योर the content of a base register is added to the address part of the instruction in order to obtain the effective address. तो effective address को कैसे find out करना है कि जो आपका instruction के अंदर, instruction format के अंदर जो address पड़ा हुआ है, you need to add that value in the content of the base register. So you are saying that you are mentioning in question number 2, base register is given consisting of sum of the value. So that value will be added to the address part of the instruction in order to calculate the final value of the effective address. Is that okay? Now I am coming to the back exercise. Yes. Acha, which questions you have to do from back exercise? This question number 8.3 is based on your section 2.2. 8.2, sorry. We'll do it just now as well. So you have to attempt this question as well. And now I think you take more time and use in solving the question assignment. One assignment I have submitted, given you based on section 8.5. But other than that, what you have to do, you have to again, the assignment, more assignments I will give you based on the entire 8th chapter, as mentioned in your course. So this question number 8.3. So today night also I will give you one more assignment based on section 8.2. I will include this question in that assignment, as well as few questions are there that is section based on section 8.4. So in total, you will be submitting me the assignment. I am extending the date. By what time you will be able to? By this weekend? Is that okay? You will have to submit me all the assignments based on 8th chapter, right? So by Sunday, By coming Sunday, you have to submit me the assignments. One assignment I already gave you, and one more assignment that I will give you by today night. The both the assignments have to be solved, and you have to submit me back right on Google Classroom. So question number 8.3 we'll discuss just now.
Make it Tuesday, ma'am.
Yes, beta.
Ma'am, please make it Tuesday instead of Sunday.
Chalo, theek hai. By Tuesday, coming Tuesday.
Thank you, ma'am.
Okay, but positively do it by that time. And then 8.3 हो गया आपका. Afterwards, question number 12. Question number 12, question number 11, you can note it down just now. Question number 3, question number 11, question number 12. I'm going. And question number 13. It's a similar kind of a question as mentioned in chapter 5. Afterwards, question number 14, you can refer to the solutions. It is mentioned there. Question number 14 you can attempt. And question number 18. Right? Question number 18. So, and moreover, this question number 20 as well, note it down just. Ishika, note down all these questions and place it on the WhatsApp group. The questions that I have asked to solve as in the form of the assignment. Right? Question number 20 is basically what? Perform the logic and or and XOR with the two binary strings. You are given two binary values, simply you have to find out their and or and XOR. There is nothing in it. And afterwards, Acha, this question is exactly the similar question as given in your third chapter. So you can solve question number 23, part A and part B. Only two parts, part A and part B. Just note it down, part A and part B. Sanjana or Ishika, whosoever is there, please note down all these questions and place it on the WhatsApp group. And then afterwards, right? So these questions, and other than these questions, you will have to add one more question that I will give you in the form of assignment today. That is based on section 8.4. What is the section 8.4? I'm switching to that as well. So do one thing कि आपका जो 8.5 section हुआ है 8.5 पे based, submit that assignment by today night and submit the remaining assignments, remaining questions by Tuesday, coming Tuesday. Is that okay? Is that okay or any doubt? So, and today will be the last class. Today your course will be over. Based on section 8.4, you will be given this kind of an expression. You will be given this kind of expression like, just hold on, I have to attend a call, just hold on. Now what you will be given, you will be given this kind of a question like x is equal to a plus b into c plus d. This is a kind of a expression, and you will be asked to write down a program, assembly language program, like this is the expression is given in front of you, using three address instruction, like this is a program given in a similar manner, using two address instruction, using one address instruction, and using zero address instruction. It is again extremely very important. One question of this type comes up and this expression may be changed. So note down again this question as a part of your assignment. You are given this expression and you have to write down an assembly language program using three address instruction, using two address instruction, using one address instruction, and using zero address instruction. So I am explaining this section 8.4. how to write down all these programs, though already you have done with in your 5th chapter. In a similar manner only you have to write down all these instructions. So let me open the PPT for it. I am switching to section 8.54. So that's about all your questions mentioned in your assignment that you have to submit. Now I am coming to section 8.4 and I will send the recorded video for this section as well. So it says that central processing unit, types of computer organizations, single accumulator organization, general register organization, and stack organization. It talks about the three kinds of the organizations. In single accumulator organization, single accumulator register every time is being used as a part of that in the execution of that instruction. For example, you are given a, and this kind of a single accumulator organization basically supports those kind of the instruction formats which make use of one address field. So machine instruction में से this kind of the machine instruction is written in front of you. Add X. तो इसकी micro instruction क्या होगी? How will it be internally work? कि accumulator register contents of how add X. X will become as the address of some of the operand retrieved from the memory. So that operand will be extracted from memory and added to the accumulator register, and resultant will be transferred to accumulator register. So if you view, this is a assembly language program. This is the assembly language instruction for addition of two numbers wherever one address is mentioned only as a part of this instruction. So this type of instruction is called as a single accumulator organization. And what will be its corresponding micro instruction? It will be this. You have to write down machine instruction as well as its corresponding micro instruction. Now, general register organization, how the same kind of the addition may be represented with the help of the general register organization. आपका right, single accumulator organization क्या कहता है कि at least one of the operands should be in the accumulator register. अब general register organization क्या कहता है कि here accumulator register is not must to be used. इसके में two categories हैं, 2 address और 3 address fields. 2 address और 3 address register address fields. तो 2 address instruction कैसे लिखी जाएगी जिसमें कि आप instruction में 2 address को mention कर रहे हैं, like add R1, R2. So here there is a reference of the 2 addresses, 2 operands, 2 registers. That's why this kind of the instruction is called as your 2 address register instruction, 2 address instruction. And 3 address में how the same thing may be accomplished, same kind of the operation may be accomplished. Add R1, R2, R3. So how add R1, R2 में how will it work? Contents of R1 will be added to R2 and contents ultimately will be stored back to R1. और add R1, R2, R3 कैसे काम कर रहे हैं? Content of 2 operands are initially being stored in R2 and R3. R1 will become as the destination register. These two will consist of the values of operand. These two will be added and result will be transferred back to the R1. So these are the micro instructions and these are your machine instructions. First one refers to your 2 address instruction. Next one refers to your 3 address instruction. And stack organization क्या कहता है? Stack is important concept in the memory, जिसमें आपका push and pop essentially operations are being used. Push कैसे होता है कि आपको stack की हद से how the same kind of the operations may be performed. कि आपको addition करना है या कोई और operation करना है, how the stack organization या operations push and pop may be used to accomplish that kind of a task or that kind of your mathematical, to evaluate the mathematical expression. So push X and push and pop, there are the 2 operations. Push X आपका क्या करता है? Push basically pushes, inserts this X into a stack. Stack इसका आपका होता है कहते हैं जैसे piles of a tray. That basically forms your stack. Stack is that kind of a data structure in which whatever the element is inserted first will be taken out lastly, and the moment you are going to input an element or insert an element in the stack, that will every time will become as the top of the stack. So with the help of the push operation, every time you are being able to insert a new element into the stack. So TOS means top of the stack. It will become as the top of the stack whatever the element you are going to insert. Like this is the example of the stack. One time A is inserted, then B is inserted, then A plus B will become addition is taken and again has been performed, and again resultant is being inserted in your stack. So this way, element by element, you can insert the elements in a stack, and ultimately from the top of the stack, the elements will be taken, popped out or taken back. So in push X, how X will be inserted into the stack, and it will become as the top of the stack. Pop, what it will do, whichever is the topmost element, that will be taken out and will be stored in memory at the location X. पॉप एक्स कैसे काम करेगा कि जो भी टॉप ऑफ द स्टैक है, जैसे a प्लस बी है, इट विल बी टेकन आउट इन एंड it will be taken out from the memory, from the stack TOS, top of the stack, and that will be stored in some of the address X in the memory. So basically you need to, whenever you're going to talk about the stack organization, you need to take care of these two operations, push and pop and add operation. अब इसमें add कैसे काम करेगा, इस add को, this is the example of zero address instruction. Using the stack organization or using zero address instruction, how this add is accomplished. So add से पहले push X already has been done. Push, with the help of the push X means A already has been inserted. Again, similarly, one more time B already has been inserted, and then add will what it will do? It of its own will do the addition of the two topmost element of the stack, and that ultimately will become as the topmost element. So, matlab A and B are the two topmost element. Add itself will do the addition of those two operands, and that ultimately will become as the top of the stack. So, what will be the zero address instruction? Add only. No address is being specified of its own. It will work on the two topmost elements of the stack. And what will be its corresponding micro instruction? That whichever are the two topmost element, those will be added and will become as the topmost element of the stack. So this way the stack organization works. This is an assignment question. Given the following expression, write down an assembly language program using two address instruction, three address instruction, one address instruction, and zero address instruction. Assignment 2. Given the following expression, you have to incorporate as a part of your assignment these questions. Given the following expression, write down. अब आप इसमें change हो गया, देखो expression में यहाँ plus था, यहाँ minus कर दिया. The only minor change is there. Write down as assembly language program using two address instruction, three address instruction, one address instruction, and zero address instruction. So how you will be doing? This is a solved question in your chapter. You are given a mathematical expression x is equal to a plus b into c plus d. So how you have to write down a three address assembly language program. This program is called as assembly language program using three address instruction. How you will be write down in order to accomplish this evaluation? So first of all, what you have to do? A plus B means add operation has to be applied on A and B. Then add operation has to be applied on C and D. Then ultimately, whatever is the resultant expression, those need to be multiplied with each other. So that means multiply operation has to be applied. Now we'll go into the sub expressions and add. How will it? What we have to be restricted? We have to be restricted to the three address instruction, right? So how will it work? You will give this way: add R1 comma AB means three addresses explicitly are mentioned as a part of that add instruction. How internally it will work? In parallel to this, in parallel to all these machine instructions, which are nothing but the assembly language program, and you have to mention the micro instructions as well in order to show its functionality. How will it work? See, wherever there are the operands that refer to the memory, that refers to the memory address, but where there are the registers, no need to write down M of R1, M of R2. But in case of A and B, you need to write down M of A and M of B. What it means that A and B are the addresses of the operand stored in the memory. So, how will it work? That M of A, one of the operand, is being stored at the address specified by A. A is the address of the operand stored in the memory. B is the address of the operand stored in the memory. So M of A will be added plus to the M of B, and result will be stored back to R1. R1 will work as your destination register. So this way A plus B will be performed. Similarly, we come to the A, C plus D. So add R2 comma C comma D. How will it work? What will be its meaning? That you have to specify that M of C will be added to M of B, and result will be stored back to R2. Now one of the value has come up in R1, another value has come up to R2. What ultimately has to be done? These two need to be multiplied by using the three addresses. So you will give MUL. I'm holding for a moment, right? Hello, Monica, यार class है वो भी करती हूँ. Okay. right?
Excuse me, ma'am.
Yes, please.
There
Yes,
is memory B in second line.
एक मिनट बेटा,
Should be
प्लीज
B, I
ऑडिबिलिटी
think.
इश्यूज आ रहे हैं, एक मिनट एक मिनट, अब मुझे क्लियरली यस, रिपीट योर क्वेश्चन.
Ma'am, in the second instruction, R2 CD.
हाँ
So ma'am, here is a adding of M of C plus M of D.
हाँ
Here is written
हाँ,
M of
ठीक है
C.
ठीक है. Yes, very right, very right. There is a typing mistake. In place of D, B, there should be D. Right, you are very correct. Right, yeah, you are correct. Okay, now we come to the multiply operation. How the multiplication has been performed. That R1 and R2 needs to be multiplied. It will be multiplied, and ultimately result will be stored back to your sum of the memory location at the address X. Right, so this way you have to specify all these things. And what is the advantage of your 3 address instruction? Shorter programs. Disadvantage, too many bits required to represent 3 addresses. Right, so this is the way that you have to write down a program using 3 address instruction. Now we come to the 2 address instruction, that you need to write down the program using 2 address instruction, as well as you have to write down the micro instructions. Now using the 2 address, same kind of the functionality you need to achieve using 2 address instruction. Again, how will you be doing that? What you have to perform ultimately, you have to do the addition of A and B. So how will it be done? That means for making the addition of, facilitating the addition A and B, ultimately you need to have this kind of instruction. Add, matlab, what you will do, one value is referred to, stored in memory at location A, another value, another operand is being stored at some of the address B in the memory. So what you will do that, you directly cannot write down add A comma B. At least one register should be the part of the instruction. That is the restriction, right? So what you will do, you will write down add R1 comma B, but prior to that you will move value of A to R1 with the help of the move instruction. A is moved to the R1, like with the help of the move instruction. Afterwards, directly add can be applied. One value is being stored in R1, A is being stored. The operand located from Ath location is being stored in R1. One operand is being stored in R1, that is being added to the another value M of B. Right? Ultimately, these two are added, and ultimately result is stored back to R1. So this way the add will work. So what is our purpose, that we have to write down the program using 2 address instruction. So you can view that all these instructions are making use of 2 addresses everywhere. So this way you have to accomplish this this functionality. Now similarly, for in order to make the addition in C and D, again you have to repeat the same kind of the steps. What you have to do, that C will be moved to some of another register R2 with the help of the move statement, and with the help of the add statement, what will be done, R2 will be added to M of D, right? And this way R2 is already consist of the operand C, operand basically stored at location C. These two are added, and result is being stored back to the R2. Now we have come up with two values. One is being stored in R1, another is being stored in R2. A plus is being stored in R1, and R2, another expression is being stored in R2. Well, ultimately, we have to multiply these two values which are being stored in R1 and R2. So we directly can apply the multiply instruction. How will it work? It will multiply the contents of these two registers. Ultimately, the result is stored back to R1. And once the value is being there R1, but ultimately you want to save that value, store that value in the X. This is our desired result. Means this expression needs to be evaluated, and result should be stored at some of the location in the memory as per the given statement, right? So then we need to apply one more move statement. In that, the contents will be retrieved from R1 and will be stored at some of the location X1 or X in the memory. It will not be X1, it will be only X in the memory. This way it will work. So this is the way how we write down the assembly language program using 2 address instruction. And in parallel to that, you have to write down the details of your micro instructions as well. All these are the micro instructions with respect to each of these instructions. Now we come to the 1 address instruction. In 1 address instruction, it's an accumulator organization. Accumulator organization means one of the register, it is must that one of the register to be used is the accumulator, right? So, but how, again, we have to evaluate this expression using one address instruction or accumulator organization, but we have to be restricted with the same condition that these instructions are making use of one address, one operand at the moment. So what will be done, that add, how the add will work in this case, we are for making the addition, for facilitating the addition of these two operands, that prior to that one of the operand it should be stored in accumulator register. So prior to that means, prior to performing add operation, this a operand, the value from the ath location, should be loaded into accumulator register. Load A. Load A means the value retrieved from this ath location should be loaded into AC. So prior to that, we have applied load. Load, how will it work? That it will retrieve the contents from memory from this location. It will store it in accumulator register. Now one value has come up in the accumulator register. Another value directly we can specify in add as a part of your add. Now we can directly write down add B. What? How will it work in internally? That it will take the one value from memory, another value it will take from accumulator. These two will be added and result will be stored back to AC. So this way the add will work. Now this A plus B has been accomplished. Now we need to calculate C plus D. In a similar manner, we have to accomplish C plus D. Now what has to be done? That now this result of A and B is being stored in accumulator register, and this accumulator register further needs to be used in the subsequent instruction. So prior to that, the data will be overwritten, but we don't want the data to be overwritten in accumulator register, because this value further at the later step will be used. Which value? Which value of A plus B, which is being stored in accumulator register, which further will be used during the multiplication time. So what we need to do at this moment, we need to take out this value from accumulator register and we store it at some of the location in memory. That's why we have incorporated this statement store T. Store T, how will it work? It will take out the value from accumulator register, which value at present it was there. A plus B was there basically in the accumulator register. It has been taken out from accumulator register and it is stored at Tth location, some of the location Tth in memory. So this way we have taken out and we have temporarily stored this A plus B somewhere in the memory, and later in the later steps we will take out this value and will make use in case of your multiplication. Now again the same steps have been repeated for accomplishing C plus D. How the C plus D has been done? Load to AC, what it will do? The value from retrieved from Cth location will be loaded to AC, and then add D, what it will do? Then M of D will be added to the AC and result will be stored to AC. Now AC consists of one operand as C plus D. Now further, in order to accomplish this multiplication operation, what will be done? That one location is being stored in the memory with the help of the store statement at Tth location. At the Tth location. So multiply, how multiply will work? If we write down this statement in this manner, multiply T. So what it will do? It will take out the value of A plus B stored at Tth location, and it will multiply. It should be multiply in place of your plus. Again, there is an error. It should be multiplication operator. So it should be. It will be taken out and it will be multiplied by AC. And AC at present, what it consists of? It consists of the previous added value. Previously added value, that means it consists of C plus D. Now the C plus D, basically the operands retrieved from these locations, those are added in C and these are multiplied with M of T, and M of T consists of A plus B. So this way, and ultimately the result will be stored back to AC. And now at this moment, the result is being stored in accumulator register. But as per the given instruction, as per the given specification, this resultant value needs to be stored at some of the location at memory, in memory at exact location. So what we need to apply then, again we need to apply one more store instruction. We'll write down store X means the value, resultant value will be taken out from accumulator and it will be stored back to the memory at some exact location. So this way you will be given some kind of the expression and you will be asked to write down the assembly language program, either 3 address instruction, 2 address instruction, 1 address instruction, or the 0 address instruction. Now I am switching to that next part. 0 address instruction. It is also called as the stack organization. Now you can go through all these instructions. It is not essential all the time that all the instructions essentially are making use of 0 address instruction. Means it will be a mix and match kind of a program. means few instructions will be of the type zero address instruction, and few will be having the one address instruction. So otherwise it cannot be made feasible to write down this program. Okay. So at this you can view add and multiply are the examples of zero address instruction, and whereas push and pop, those are being used, are the one address instruction. So it will be a mix kind of a mixed category of the instruction, though we are going to write down zero address instruction. That means few of the instructions may be zero address instruction. Again, how to accomplish this expression? First of all, we have to make use of stack organization. That means essentially we'll have to make use of push and pop operation. We'll write down push A. After the push A will become as top of stack. Again push B, one more element will be inserted into the stack, and that will insert value B in the top of the stack. So now B will become as the top of the stack. Now whenever you will give add and you will not specify any operand, a zero address instruction. So what it will do, it will do the addition of the two topmost element of the stack of its own. So A and B will be added, and that ultimately will be inserted into the stack, and that will become as the top of the stack. Now push C, what it will do, C will be inserted, and that will become as the top of the stack. And prior to that, the A and B will be taken out, will be popped out of its own, though we need not to specify those. Only A plus B will left in the stack now. Now push C, C will be inserted in stack, that will become as top of the stack. Push D, D will be inserted into the stack, and that will become as the top of the stack. And earlier A plus B was there as one of the element of the stack. And now when we give the add, what it will do, it will add these two topmost elements, and these two will be added and will become the top of the stack. But prior to that, C and D will be popped out. Now only two elements are left in the stack. One is the A plus B, earlier stored in the stack, and afterwards C plus D was pushed in the stack. Now two topmost element, one is A plus B, another is C plus D. So what multiply will do, multiply will multiply these two elements, or two topmost elements of the stack, and that ultimately will become as the top of the stack. And now this top of the stack, this multiplication value ultimately needs to be stored in memory at some of the location as X, and it needs to be taken out from the stack, and it needs to be stored at some of the location in memory at some XF location. That's why the pop operation has been applied. Pop, what it will do, it will take out that value top of the stack. This is the top of the stack multiplication value, and it is stored in memory at some of the location as XF. So what will happen, top of the stack will be stored in some of the value in memory at XF location. So this way you have to write down the program using zero address instruction. So that's all about your section 8.4, and I told you to solve the back exercise question, question number 12. That was nothing but a similar kind of a question given in your back exercise. Question number 12. Question number 12. It was a question of a similar type. Write a program to evaluate the arithmetic statement. Here some of the arithmetical operations are given, including addition, subtraction, multiplication, and division. And downside also is there. Numerator and denominator are there. Using a general register computer with 3 address instruction, using a general register computer with 2 address instruction, using an accumulator type computer with 1 address instruction, and using a stack organized computer with 0 address operation instruction. So in a similar manner, you have to, the way I have told you, in a similar manner you have to write down the program, assembly language program for this given expression, to solve this given expression. Now I come back to section 8.2. That is the last section of this chapter. Though brief description of 8.1 is there, 8.2 is there, 8.3 is there. That is a brief description and theoretical part. You can study of your own. The main numerical question that comes in your that generally comes in your final exams. So I would like to discuss that question. This is a general register organization. If you do talk about section 8.1, it is only introductory part. What are the different components of your CPU? Control unit is connected with your register set, and arithmetical logical part is there. Even you have done in your CPU simulator as well. These are connected with each other with respect to the control signals. The data is being transferred from one unit to another, and different arithmetical and logical operations are applied over the data which is stored in the registers. Essentially, we are going to talk about the three components: register set, arithmetical logical unit, and control unit. And the same is illustrated in section 8.2. You can view that this is a register set. Here we are going to talk about 7 registers from R1 to R7. You can view this is a basically what we are going to talk about. We are going to talk about the CPUs, the internal structure of CPU. This is register set with common ALU, means connectivity of how these register arithmetical logical unit are connected with each other, and along with there are the control signals. Select A, select B, OPR, and select D collectively will be counted as a part of your control unit. It will be counted as it basically based on this diagram that register set. We are going to talk about the transfer of data and that evaluation of the data and connectivity of the data from register set to ALU and vice versa, and with respect to the activation of different control signals that comprise your control unit part. So here this is your register part that is going to support 7 register from R1 to R7, and then afterwards there is arithmetical logical unit. We are going to talk about the two operands. Some of the arithmetical logical operation will be applied on the two operand which are coming from either of this register. One operand will come out from this register, another operand will come out from this register, or some of the from some external output can also be there. From the keyboard also the some kind of the output can be given. Right, so we are focusing on A and B. A means at the moment one of the value will be selected from these seven register. So here for the selection purpose, here the multiplexer is being used. Multiplexer, I told you the function of multiplexer. What it does that if you are having 2 raised to power n, 2 raised to power n number of inputs, then it will facilitate the selection of one. It will select one input line and redirect it to the output line. So similarly, it will select one of the value from the given register and it will basically redirect it to the output line A bus. Okay, that will become the value of A. Whichever is the value of either of the register value from either of the register is selected, and that ultimately will become as the value of A operand. And which value will be selected at the moment, that will depend on the different combination of select A. These are the select pins. I told you how the select pins are to be decided in multiplexer. If there are the 8 2 raised by 3, it is converted in terms of 2 raised by 3. Here though the 7 registers are shown, but at the most you can make the combinations on the basis of the 8 input registers. So 2 raised by 3 it will be converted. So that means 3 select pins will be there, and on the basis of select pins it will decide that the specific kind of a combination will decide that which of the value is coming from which of the register, and that is being selected by the multiplexer as the final output value. Similarly, for the another output also, it will select one of the value from either of these registers, and again the select pins will be 3, that will be termed as your select B, and that will comprise your part of the control unit. And again its different combination will decide which of the value will come from the register, and it will become as the value of your final output line B. Now again, now we come down कि आपका one value has been placed on this line, another operand is being placed in B line, and then which of the operation will be performed over this operand, that again will be decided by this control signal OPR, 5-bit control signal. The different combination of OPR will select whether it will be add operation, or it will be a multiply operation, it will be a shift operation, or any other kind of the operation. So it will depend on the binary value of OPR. That again will comprise your part of the control unit or the control word. This will be all are the control signals. And now once that operation has been performed by the arithmetical logical unit, the output will come out, and this output will be stored back to some of these register. Now again, there will be a decision that which kind of the register these register, and then which kind of the register has been chosen. That will be sorry, that will be selected on here the decoder basically has been incorporated. That will be decided by the decoder. And again, there are the select pins with the 3 inputs are there and 8 output lines. Either of the register, in either of the register, the output value, the resultant value will be stored. So so these collectively select A pins. How many pins? 3 pins are the select comprise your select A pins, and select B pins. 3 pins for select B are this one, and the 5 pins for OPR and 3 pins for select D. So in total, these are 5 and 3, 8 and 3, 11 and 3, 14. These 14 pins collectively are called as a control word. It comprise your control word. In exam or in batch exercise question, this kind of a question would be given. Key, just find out the value of the control word, 14-bit control word. Now, what will be the value of select A, select B, select D, and OPR? Ultimately, what will be the value of the control word? Like if you do come down, this kind of a question would be given to you. To control unit that operates the CPU bus system directs the information flow through the register and ALU by selecting the various components. For example, to perform the operation, this operation is given. The control must provide binary selection pins to the following. How will it work? See, how will it go step by step? First one, multiplexer. Multiplexer A, what it will do? A selector. Select A, what it will do? It will to place the content of R2 into the R2 ki value will be placed in bus A. What has to be done as per this given expression? Content of R2 has to be added to the content of R3. Ultimately, result has to be transferred to R1. How internally the CPU will perform this activity? Content of R2 will be placed on bus A. Okay. Content of R3, R2 and R3. R3 again will be, some of the register will be chosen by multiplexer, and that will go through this multiplexer, and that will be placed on B line. And so R2 will be, so R3 will be chosen. Some of them is specific. Specifically, R3 will be chosen as per the specific value of your multiplexer. Select B. These two will be added, and ultimately the result will be stored back to R1. Now, what are the possible values? This has to be done. Control word आपका क्या करता है? Now this table will be given in front of you. If the table is not given, so all these are in a specific order. So you need to memorize these value. कि binary code में what are the possible combinations? 000, 001. I told you that 8 combinations should be there. 7 are the registers and 1 value is coming from external input. So in total, there are the 8 possibilities. It is coming from the keyboard, either from keyboard or either from either of the register. So what kind of a question may come up in your exam? You are given this table, and on the basis of this, given this register transfer statement, you have to write down the value of the control word. This way the question may come up. क्या है आपका कि बाइनरी कोड की क्या पॉसिबल वैल्यूज हैं? 000, 001, 010, 00011, 100, 101 and 110 and 111. और आपका सिलेक्ट ए, सिलेक्ट बी, सिलेक्ट डी कैसे काम करता है? इन केस आपका बाइनरी कोड की वैल्यू, सिलेक्ट ए की वैल्यू 000 है, so that means the input value is coming to the input line, A line पर from some external input से, कीबोर्ड से आपका कोई डेटा आ रहा है in place of any of the register. That means directly data is coming from the keyboard to the A line, or the B line is coming from the external input. In case the value of your select A, select B and select D is 000. और none का क्या meaning है कि data is not going to any of the register, rather it's going to some of the external output, right? और whenever the value of binary code is 001, select A का भी 001 है, तो क्या है कि R1 register is being chosen and its value is brought has been chosen as the final input value A. It will work as the final input value A. If value of select B is 001, so that means again R1, the same value of R1 is chosen as the final value of B. Or select D, मतलब कि R1 में ही डेटा जाएगा. 0 1 0 in all the cases R2 will be selected. 0 1 1 में in all the 3 cases R3 will be selected. 1 0 0 में everywhere R4 will be selected and so on. Now based on this given question, what will be this? The value of your control word. क्या क्वेश्चन है आपका? R2 plus R3 data is being transferred to R1. R2 मतलब पहला वाला ऑपरेंड आपका सिलेक्ट ए है, तो R2 में सिलेक्ट ए की वैल्यू क्या होगी एज पर द टेबल? सिलेक्ट ए में R2 कब सिलेक्ट होता है? whenever its value is 0 1 0. So that means इसका कंट्रोल वर्ड क्या हुआ? We are talking in terms of the control word. Control word we can write down. आपका कंट्रोल वर्ड यहाँ पे इस एग्जाम्पल के लिए शो किया हुआ है. In a similar manner, it has been written for, so we'll take this example, R2 minus R3. And moreover, one table is this, which is given, and moreover, one more table is given कि आपका जो ALU, जो different arithmetical operations को support कर रहा है, ALU, that is decided by the different combinations of OPR operations में. How many pins are there? 5 pins are there. So 5 pin में it is built in कि ये कौन से वाले ऑपरेशन को सिलेक्ट कर रहा है. It is 5 pins की वैल्यू यही होगी आपकी. अगर ये ऑल आर जीरोस तो ट्रांसफर ए को कर रहा है, 0 0 0 0 1 है तो इंक्रीमेंट को कर रहा है. सो इफ इन एग्जाम दिस क्वेश्चन कम्स, तो बाय रूल दिस वैल्यू कैन नॉट बी मेमोराइज्ड. This value should be given as a part of your question, then only you will be able to solve this question. And if it is not given, तो at the most you can learn it for add और and के लिए कर लेना. ये मेमोराइज कर लेना क्या वैल्यू होती है. 0 0 0 1 0 होती है आपकी ऐड के लिए और 0 1 0 0 होती है आपकी एंड के लिए. But by rule, all this value should be specified as a part of your question. So अगर आपको ऐसे वाला इंस्ट्रक्शन करना है कि R2 minus R3 the data will go into the R1, इसके लिए if you need to write down the value of the control word, कैसे करोगे? तो कंट्रोल वर्ड क्या होता है? I told you the definition of control word कि select A, select B, select D, OPR, all these 14 bits control word, the size of the control word is 14 bits. All these 14 bits comprise the value of your control word. मतलब आपको बताना है कि अगर आपको गिवन एक्सप्रेशन ये है तो सिलेक्ट ए की पॉसिबल वैल्यू क्या होगी. R2 के केस में यू कैन गो टू दैट, अगर गो टू दैट टेबल कि अगर R2 कब सिलेक्ट होता है, व्हेन इट गेट्स सिलेक्टेड, यू हैव टू गो बाय दैट टेबल. व्हाट टेबल सेज, वेयर इज दैट टेबल? आई जस्ट नाउ आई शोड यू. दिस इज अ, सो R2 सिलेक्ट होता है व्हेन सिलेक्ट ए की वैल्यू आपका क्या है? 0 1 0 है. R3 कब सिलेक्ट होता है? जब इसकी वैल्यू 0 1 1 है, राइट. सो जो इसके इंडेक्स है वही इसकी बाइनरी वैल्यू होगी. डू रिमेंबर दिस थिंग. R2 है तो 0 1 0 2 होगा. R3 है तो 3 होगा, 0 1 1. सिलेक्ट बी की R2 माइनस R1 3 होना है और देन रिजल्ट हैज टू ट्रांसफर टू R1. तो सिलेक्ट बी में R1 क्या होगा? 0 0 1 होगा सिलेक्ट डी में. और OPR सब्ट्रैक्शन क्या होगा? यू हैव टू गो बाय दैट टेबल कि सब्ट्रैक्शन का क्या गिवन है ऊपर इन द टेबल. You can come here, you can find out subtract operation का क्या given है. 0 0 1 0 1 from the table itself. You have to make use of this value. So ultimately this value will become as the final value of your control word. Like if you in a similar manner you have to solve the back exercise question. Question number 3. I come to the back exercise question number 3. This is your question number 3. Simplify the control word that must be applied to the processor to implement the following micro operations. Right? So you in a similar manner you have to write down the control word for each of the part. कि आपका R2 plus R3 is being added and the result is transferred back to R1. तो इसमें प्लस वाले ऑपरेशन का OPR देख लेना टेबल से. सिमिलरली ट्रांसफर वाले का OPR देख लेना. सिमिलरली सब्ट्रैक्ट या डिक्रीमेंट वाले का देख लेना और शिफ्ट लेफ्ट वाले का देख लेना. और इनपुट यहाँ से आ रहा है, एक्सटर्नल इनपुट आ रहा है, तो क्या होगा? तो कंट्रोल वर्ड यू हैव टू फ्रेम 14 बिट कंट्रोल वर्ड की वैल्यू लिखनी है रिलेटेड टू इट. So that's about this chapter. If you are having any kind of a doubt regarding this chapter, you can ask. Then I will switch to the back exercise question of chapter 3rd. Let me know. Do you have any doubt regarding this chapter? Now I am switching to the back exercise, the doubts of the back exercise of your chapter 3rd.